move it. I like to move it, move it. I like to move it, move it. You like to move it.
Welcome to a brand new episode of I Like to Move It, the podcast where we explore the world's most powerful, fascinating, and sometimes surprising material flows. I'm Mr. R, and I'm here with someone who knows exactly how to make cement sound exciting.
Thanks, Mr. R. I'm Alice, and my mission is to make sustainability and engineering accessible, engaging, and why not, thrilling. Today, we're diving into one of the most used yet underrated materials in the modern world, cement.
That's right, cement is everywhere. It's in the foundations of your home, the roads you drive on, the bridges you cross. But what people don't usually see is the complex and highly engineered world inside a cement plant, especially how material moves within it.
And as we like to say here, if it moves, we want to talk about it.
So let's paint a picture for our listeners. It all starts in the quarry. Giant excavators extract limestone and other raw materials like clay, shale, and iron ore, which are then transported into the cement plant.
And here's where the magic, or more precisely, the engineering begins. From the moment the raw material enters the facility, material handling systems take over. This includes an extensive network of belt conveyors, bucket elevators, hoppers and feeders, designed to move bulk materials seamlessly across production stages.
First, we have crushing. Big rocks are broken down into smaller chunks using jaw crushers and hammer mills. Then, they're ground into a fine powder in raw mills, where vertical roller mills or ball mills reduce them to a size suitable for chemical transformation.
Then comes the preheating and calcination stage. The fine material is heated in a preheater tower and then sent into the rotary kiln, a massive, slightly inclined cylinder rotating at a few RPM, where temperatures reach up to 1,450 degrees Celsius or 2,642 degrees Fahrenheit.
That's where the raw material becomes clinker, a gray nodular material that's the main ingredient in cement. Once cooled, it's mixed with gypsum and sometimes other additives, then ground into the fine powder we know as cement.
Now here's a critical part of the story. Cement plants are industrial giants, and they need to move thousands of tons of material per hour, every single day. This requires ultra-reliable components.
If a single conveyor pulley or idler fails, it can shut down production for hours or even days. That's lost revenue, safety risks, and a massive waste of energy.
Exactly. That's why using high-quality components from conveyor rollers to motorized pulleys is not a luxury, but a necessity.
Companies like Rollmaker are at the forefront here. They supply specialized components for bulk material handling, particularly for the cement, quarry, and tunneling industries. We're talking about idlers and motorized pulleys built for high loads, extreme environments, and 24/7 operation.
And it's not just about durability. These components help reduce maintenance downtime, improve energy efficiency, and even enhance worker safety by minimizing mechanical failures.
Plus, in cement plants, dust is the enemy. High-quality sealed components prevent contamination and reduce the risk of fires and wear-related breakdowns.
All right, time for some big numbers. According to the latest data from 2023, the world produced around 4.1 billion metric tons of cement.
That's more than 500 kilograms of cement for every person on the planet. And leading the charge is, you guessed it, China, which produced more than 2 billion tons, accounting for over 50% of global output.
Right behind China, India produced over 400 million tons, and Vietnam, Indonesia, and Turkey are also climbing fast. The United States came in at around 91 million tons, mostly used for domestic infrastructure.
Africa's largest producer is Egypt, with over 50 million tons, while in South America, Brazil stands strong with around 60 million tons in annual output.
Interestingly, many of these countries are also investing heavily in upgrading their cement plants, not just to increase capacity, but to meet new environmental and safety standards.
And this brings us to the green side of things. Alice, hit us with the truth.
The cement industry is responsible for roughly 8% of global CO2 emissions. That's largely due to the calcination process, where limestone, calcium carbonate, is heated and emits carbon dioxide.
That sounds bad.
It's a challenge, yes, but it's also a huge opportunity. The industry is testing and deploying solutions like low-carbon cements, clinker substitutes, like fly ash or slag, carbon capture and storage, CCS, and even electric kilns powered by renewables.
And don't forget material handling. Upgrading to energy-efficient motors, smart conveyor systems, and dust containment technologies makes a real difference.
Absolutely. For instance, Rolmeka's motorized pulleys are internally powered and hermetically sealed, meaning they reduce the risk of dust contamination and require less maintenance while using less energy than traditional systems.
That's engineering that moves us in the right direction, literally. Time for some fun cement trivia. Did you know the Romans used a form of cement over 2,000 years ago to build harbors, and some of those structures are still standing?
Yep, and modern researchers are studying that ancient formula to create more durable, less carbon-intensive cement blends.
Also, the world's largest cement plant is in India, capable of producing over 10 million tons per year in a single site.
And get this, in 2023, the average cost to produce 1 ton of cement was around $100, depending on region, raw materials, and energy prices. That means this is a multi-hundred billion dollar global industry.
So Alice, we've talked about how material moves in a cement plant, but it's not exactly like pushing a wheelbarrow full of gravel, right?
Not even close. In a typical cement plant, you're handling abrasive, heavy, high-temperature materials 24 hours a day. We're talking about tens of thousands of tons per day being moved from the quarry to crushers, then to raw mills, preheaters, kilns, and finally to storage and shipping areas.
And each one of those movements is a potential failure point if not properly engineered.
Exactly. Let's break down some of the challenges. Limestone, clinker, and coal are extremely abrasive. This wears down conveyor belts, idlers, and chutes. Plants need to use high-strength steel alloys and rubber-lined components just to survive the daily grind, literally.
So maintenance teams are constantly fighting friction?
Friction and erosion. And if a belt tears or a pulley gets misaligned, you're looking at hours of downtime.
I've heard that cement dust is not exactly friendly.
That's putting it mildly. Cement dust is fine, invasive and hazardous. It clogs bearings, damages motors, and poses serious respiratory risks for workers.
Which is why sealed systems like Rolmeka's motorized pulleys are such a big deal.
Exactly. A hermetically sealed drive motor, enclosed inside the pulley itself, keeps out dust and moisture, extending lifespan and reducing the need for constant cleaning.
Let's not forget the heat. We're talking over 1,400 degrees Celsius in the kiln area.
Yes, and even downstream, materials can come out of the cooler at 200 to 400 degrees Celsius. Conveyors and hoppers in these zones have to be built from high-temp resistant materials, often with cooling jackets or fireproof linings.
What about space? Some of these plants are massive, but the internal layouts can be tight.
That's a big challenge. Material sometimes needs to move vertically up to 60 to 80 meters, especially from silos to preheaters or bagging stations. That's where bucket elevators, screw conveyors, and high-angle belt conveyors come in.
And all of that has to happen without spillage, jamming, or material degradation.
Exactly. Inconsistent feed rates or poor conveyor design can cause clogging, overflow, or even structural damage.
Let's talk power. Moving this much material must take a lot of juice.
It does. Bulk material handling accounts for up to 30% of a cement plant's energy consumption. So even small gains in drive efficiency, low-friction idlers, or variable frequency drives, VFDs, can have a huge impact.
And motorized pulleys again help here, since they're more efficient than conventional gear motor setups.
Right. Their compact design reduces transmission losses, and they're easier to maintain, which lowers the total energy and operating cost.
What about external challenges like rain, snow, or desert heat?
Great point. In places like Brazil, India, or the Middle East, conveyors may run outside for hundreds of meters. You need UV and weather-resistant belts, drainage systems, and sometimes enclosed conveyors to protect both the material and the equipment.
So to sum it up, moving materials in a cement plant is like orchestrating a heavy metal ballet, one where every roller, belt, and pulley has to perform perfectly, under constant stress.
Beautifully put. And when it comes to selecting the right components, quality is not optional. It's essential for safety, uptime, and sustainability.
So what did we learn today? First, cement production is a monumental process with tons of moving parts literally.
Second, every one of those parts, especially in material handling, must be high quality, efficient, and built to last. Otherwise, the entire system can fall apart.
And third, the path to a more sustainable future isn't just about what we build, it's about how we move the materials to build it.
Exactly. If we want greener cities, cleaner infrastructure, and smarter industry, we need to look at every link in the chain.
Well said. And let's not forget the human side of this story. The engineers, the maintenance teams, the plant operators, they're the unsung heroes keeping the world turning, 1 ton of cement at a time.
Absolutely. They're working in tough conditions, handling complex systems, and constantly innovating to make things safer, cleaner, and more efficient.
So to all our listeners out there, whether you're an engineer, a student, a sustainability enthusiast, or just cement curious, we hope this episode gave you a new appreciation for what it takes to move mountains, literally.
And next time you walk on a sidewalk or pass a building site, remember, behind every concrete structure is a world of motion, precision, and technology, from quarry to kiln to crane.
That's it for today's episode of I Like to Move It. If you enjoyed it, don't forget to subscribe, leave a review, and share it with your fellow movers and shakers.
And if you've got questions, topics you'd love us to cover, or stories from the field, drop us a line.
Thanks for moving with us. See you next time. Stay safe and keep it awesome.
I like to move it, move it. I like to move it, move it. I like to move it, move it. You like to